time for math. I know how much you guys like geometry, so we're going to get excited about proving triangles congruent. So we're going to do section 4 today. This PowerPoint just keeps going for section 5, but I'm not going to bore you with 2 sections. We're just going to do 1. So here we go. Geometry with Mrs. Norris, Chapter 4, Section 4. Let's start with a quick warm-up. Name the angle formed by ray AB and ray AC. Now I know what you're doing right now. You're drawing a ray, starting at A, going out to B. And then you're drawing another ray, starting at A, going out to C. See if you can figure out the name of the angle. Alright, we'll talk about it tomorrow. Here's the beginning of your notes. You should be writing these down. Definition of congruence. We've already talked about this before. It means same size, same shape. If you remember yesterday, we proved all 6 parts of the triangle is congruent. That meant the triangles were congruent. Okay, same size, same shape. You should already have that down from yesterday. Yesterday, we said to ourselves, how much do we need to know? And we decided we needed to know 6 things. Okay, let's write those out. If I write out those 6 things, remember, top 3, S's. What's S stand for? Not silly. S stands for the side of the triangle. That's why they're all segments here. These 3 are the sides, and these 3 are the angles. We had 3 A's, 3 S's, total of 6. We needed to know all 6 to say that triangle ABC was in fact congruent to triangle DEF. So, let's start with some new theorems. Up until now, we needed all 6 parts congruent. Do you think you need all 6? This guy's shouting at you. No, you don't need all 6 anymore. Let's celebrate. These proofs are going to be shorter. Here are the 4 main theorems we're going to learn. We're going to start with the first 2 in this section. All right, let's start with SSS. I introduced to you side, side, side. Isn't that clever? We call it SSS. All right, side, side, side. SSS. If you know that one side of the blue triangle is congruent to its corresponding side in the red triangle, and BC, which is in the blue triangle, corresponds to EF, etc., you will notice we have an S, an S, and an S with just these 3 and no angles. You heard me right. No angles. Just the 3 S's. We proved that the triangles are congruent. We call it the side, side, side triangle congruence theorem. You will be abbreviating it simply by SSS. The next one that we're going to talk about is side, angle side, conveniently abbreviated by SAS. A very important note to make about SAS. This A is the middle, okay? It's in between the S's. Well, guess what? The A better be the A between the 2 S's. In other words, it's called the included angle. You need to think of the A as the cream in the Oreo and the S's as the Oreo. Is this angle right here between the 2 sides of the Oreo? Absolutely. So D would be the cream of the Oreo. Yummy. If these sides are congruent and their included angles are also congruent, we say the triangles are congruent using SAS. Alright, let's try it. Let's first just practice finding the included angle. I've labeled for you here these 2 sides. Where would the included angle be between these 2 sides? We'll take your pencil and trace down and over. You will notice that the included angle is right there at G. On these 2, if you take your pencil and trace this side and this side, the included angle is right here, angle I. And if you trace your pencil on this side and this side, you'll see that the included angle is right there, or H. Side angle side. The A is between the S's. The A is the cream, the S's are the Oreo. Alright, let's do this really quickly. We're going to name the included angle. What's the included angle for side YE and side ES? Notice the color coordination here. E is the included angle. What's the included angle for ES? This one. NYS. S is the included angle. The bottom one, Y is the included angle. Okay, if you haven't realized it by now, that's important. Very common student mistake. You see an A, you see two S's, you think you got SAS. No, you don't. Not unless the A is between the two S's. Alright, here's some very important thing. These one-step proofs we've been working on, what is something that's always brought to our attention on both the in-class worksheet and the homework worksheet? You have to look for the reflexive property. This happens when two triangles share a side or are basically right smashed up adjacent to each other, for an example in this picture. This triangle right here shares this side with this triangle right here. And that happens when they're butt up against each other, and that's why we learned that silly reflexive property from chapter 3. The other one that's important to look for, the vertical angle. Some of you are still having trouble with this. Just look for your giant X. Remember that vertical angles are always congruent. You're never going to be given that. You're just going to be given a picture, and you got to know that this angle right here is congruent to this angle right there. Okay? All right, let's try some. These are 4 pictures that we're going to see if we can apply SSS or SAS simply by looking at the markings in the picture. Markings in the picture, you know, are your givens. Somebody's telling you that this is true. So what we're going to do is we're going to practice marking what we see. First thing we're going to do is look for our reflexive and vertical angles. In this picture, I see that this side is shared with this side, so I mark it with a congruent symbol. The next thing I do is I label in one triangle only. Every side gets an S. So those two have S's. Notice I'm only doing one triangle, not both. That'll get confusing. And then every angle gets an A. Very smart. I know you were saying that to yourself. You can notice that this A is in between the two S's, so we say SAS. Alright, next picture. I see an S and an S. Is that all we got? No, because you recognize that this is a vertical angle. So first thing we do is mark those as congruent because of vertical angles theorem. Now we're going to mark our S, A, S. You'll see clearly that we have side, angle, side, congruence. This last one here is another what I call the bow tie picture. Bow ties have vertical angles, okay? See the giant X there? So we say those two angles are congruent because of vertical angles theorem. Again, we have side, angle, side. I don't need to label this one. It's real similar to that one. This last one here should look a lot like this one, except we're going to label this side right here. This side is congruent to in both triangles because it's shared. We call that the reflexive property. We're going to put an S there, an S there, and an S there. And this one is different than all the rest because it is a side, side, side similarity. Whenever you're doing these picture problems for me, and you will have to do some, you need to make sure that you list the property if you use it, okay? It wasn't marked originally, so you can only add a marking if you got a property to prove. Alright, example 1 wants us to write these little mini proofs, okay, to explain why the triangles are congruent. So I'm going to go ahead and make a statements and reasons columns, and I'm going to list my 2 givens. My givens are marked in my picture. They say that AB segment is congruent to DC, so I write it, put given. They say that DA is congruent to BC, so I write it and put given. Both of these are S's, so I want you to get in the habit in your proofs of putting 2 S's. And you can see that we're either going to have side, angle, side, or side, side, side. Or we can't prove these triangles congruent, so we got to find our third one. What is the third one? Can you see that this side right here is shared between the two? You should notice that it butts up against the other one. It's adjacent. So we say that AC is congruent to AC. We put reflexive property, and we put an S there. Okay, obviously those triangles are congruent by SSS, and that's what they told me to prove. Next one is to use SAS to explain why they're congruent. Similarly, we list both givens. This time we're marking a segment congruent to another segment, so those are segments or sides. We also have this little arc mark here, congruent to this little arc mark here. So I write out my congruent angles and put an A there. Okay, so far, you always want to get organized. That's why I'm putting these little letters here. These help you realize what you still need to prove. You can see we have one S and one A. So we need one more S, and it needs to be, this A needs to be in between the two S's. So in order for this angle to be in between this side, obviously we're going to prove this side. So we're going to use reflexive, and we're going to prove that CB segment is congruent to CB. Using the reflexive property, we put our S there, and you can clearly see that these triangles are congruent using SAS. Humor me when you're doing these proofs. Use these letters, okay? It's helpful to get organized, figure out what you're doing. These are not hard. You guys can do these. Okay, let's do a full proof here. Remember, when we have a proof, we're going to list one given at a time. We're going to see if we can prove something because of that given. So let's take the first given, saying that segment BC is parallel to segment AD. If you look at this picture here, BC is up here and AD is down here. When we start tomorrow, I'll try to label these with numbers when we do the worksheets at school. You guys can add numbers at any time. These don't have numbers in them, but this angle right here that I'm pointing to and this angle right here that I'm pointing to are alternate interior angles. Whenever you have parallel, expect that you should be writing the next step saying an angle is congruent to another angle. And oftentimes it's going to be alternate interior angles theorem. Okay? The top line is parallel to this line. This is your transversal. This angle right here is congruent to this angle because of AIA's theorem. Okay, the next given is, or before we do that, let's get organized. Remember, we're going to put an A here. I'm also going to mark in my picture where that A is, okay, so we can figure out what we still need to prove. The next given that I list is this one. It's just a side of the triangle, BC and AD, so I list that there. I'm going to put an S there, and I'm going to mark it in the picture with an S. So you should figure out by now, since we've only learned two, that the theorem that we're going to use to prove these triangles congruent is SAS. Once again, we see our shared side. We reference that shared side by writing it out as a statement. We use reflexive property. We put an S, and we put the S in the picture here, and you'll see that it's clearly SAS triangle congruence. When you're finished with these kind, you really need to go back up to the proof statement and copy the proof statement. Copy these two triangles and say that they are congruent using SAS. I said steps 3, 2, and 4 because those were SAS in that order. Okay, next proof. Next proof is given to us. Now again, remember, we're going to copy a given into the statements column. And we started with this one just to make it simpler. These are saying that we have congruent segments, marked in the picture. So we just write given, okay? That's an S. That's our first part. Remember, you only need 3 now, so you should get excited. These are short. The next given that I'm going to mark is that ray QP bisects the angle. Remember, you did this perfectly. You did very well on these in the one-step proofs. So take this bisector. Notice that this ray bisects angle RQS. Okay, it's this angle up here that gets bisected. We say that it's a given. In the next statement, we say that our angles are congruent. Circle this. Reason, definition, angle bisector. Now we have an A. We mark our A in the picture. And you can see that if we include the reflexive side or the shared side, we can list that as a statement. Once again, you should notice a pattern here. This is often used in triangle congruence. We're going to put an S next to this since this is a side. These are angles, so we put an A, and then you know your last reason is SAS. Okay, kind of like a pattern. All right, that's it for tonight. You guys have a great night. I'll see you tomorrow. Make sure you have your notes written down, and we will go over some more examples tomorrow.